Yeah, good morning, students. Welcome to my YouTube channel. If you have not yet subscribed to my channel, please subscribe. So in this video, I will be discussing on how to represent IPv6 address. Okay. So before going for representation, so let us see what is the size of an IPv6 address. It is of 128 bits. In the previous videos, I might have told you that the size of an IPv4 is 32 bits, whereas IPv6 is 128 bits. Okay. So this IPv6 address can be represented in two forms. One in binary form, the other one is in hexadecimal colon notation. Same thing we have seen in IPv4 address also. There also we have represented hexadecimal colon notation as well as in binary form. Okay. Now let us first see how to represent IPv6 in hexadecimal colon notation. So this is what decimal colon notation. You can see an 128-bit address has been divided into 8 sections, or we can call it as 8 blocks. This is block 1, block 2, block 3. Like that we have totally 8 blocks. Each block will contain 4 hexadecimal digits. Like we have F, D, E, C. Like that totally we have 8 blocks. Each block will contain 4 hexadecimal digits. Thereby we have 32 bits or 32 hexadecimal digits. And each block or section is separated by a colon. So this is how you need to represent the hexadecimal colon notation. The other way is to represent in binary form. Binary form is very easy. Since each block will consist of 4 hexadecimal digits, which will occupy totally 16 bits, each number will occupy 4 bits. Okay. So the maximum number it can take is 0 to 15. That is nothing but 0 to F. Similarly, this D can occupy 4 bits, E can occupy 4 bits, and C can occupy 4 bits. So totally there are 16 bits. 16 into 8 blocks, 128 bits. So there you can see each hexadecimal digits should be represented in binary using 4 bits. For example, F is represented using 1111, 4 bits. D, nothing but 13, is represented as 1011. Similarly, E, nothing but 14, is represented as 1110, and C, 12, is represented as 1100. So in this way, each digit, hexadecimal digit, is represented using 4 bits. This is how you are going. And last one you can see, last block. We have FFFF. All will be ones. First F, second F, third F, fourth F. This is what your block. So in this way, and please remember, don't put any colon after each block. No, continuously you need to write. This is how you need to represent in the form of binary. Hope you understood. This is binary form. This is hexadecimal colon notation form. Okay. Yeah, I want to tell you one more thing. Since this IPv6 address is somewhat 128 bits, which is of bigger size, we have some conditions where you can make it into some simpler form, or we can call it as an abbreviated form. We need to know 3 conditions whenever you are going to simplify the original IPv6 address. Okay. So this is what your original IPv6 address. You can simplify it using 3 conditions. First condition, if any block consists, for example, this is 0074. Okay. If any block contains leading zeros, those zeros can be omitted. Just you can write it as 74. But if it is having 7400, Don't omit these numbers, zeros. Okay. Only leading zero should be omitted. Second case, here you can see 0, 0, 0, 0. If you have continuous zeros like this, then you can replace it with a single zero. Okay. And if you have continuous zeros like this also, so here also this is 0, colon. Here also we have continuous 4 zeros, you can write as 0. Here also we have continuous 4 zeros, 0. If you get to the second stage, continuously zeros like this whole thing can be represented like this, quote, and one more colon. That indicates that there are consecutive zeros inside. This we call it as a gap. Here you can see that. Okay. Don't worry, if you are not understood, we can solve one example. So this is the last condition. So first condition is this one, second condition and third condition. So you can apply these three conditions to the original IPv6 address and you can make it to simplify. So let us solve one example. So these are the assignment questions for you people. However, first one I will solve, remaining two you can put the solution in the comment box. Okay. Let us see how to resolve this. This is what your original IPv6 address. So now I want to simplify it into its normal form. For example, as I told you, 2001. There is no simplification here. Directly you can write as it is. 0DB8. Yes, I will omit the first 0 because the leading zeros can be omitted. DB8 codes. Here there are continuous 4 zeros, so I will write only 1 0 here, colon. Again continuous 4 zeros, so I will write 1 0, colon. Again we have continuous 4 zeros, 1 0 I will write, colon. Again continuous 4 zeros, single 0, colon. Continuous 4 zeros, again single 0, colon. And here there are 3 reading zeros, so I will omit it, I will just write 1. Okay. According to the third condition, you can see there are continuous zeros here till here. So what I can write now, 2001, colon, DB8, colon. All these I will write just write a one more colon over. So this is the gap where there are continuous zeros and then 1. So this is the simplified form of this IPv6 address. Now you can solve these two addresses and put the solution in the comment box. So hope you enjoyed the video. Thanks for watching and subscribe my YouTube channel for more videos. Bye.